Hello everyone, welcome back to my channel. My name is Dr. Yogita Bisht, and in today's video we will study about the difference between the normality and molarity. This is a continuation of the previous topic that we started with the mole concept. There I explained everything about the moles and how to calculate the number of moles. There are different ways, and in today's video we will try to apply that knowledge here. Alright, so we will start with molarity. So what is molarity? Molarity is represented by capital M. Molarity. It is the number of moles of solute. Remember, moles of solute present in per liter of the solution. Volume of solution in liter. So, here you can see terms solute and solution. These top terms are very important to understand because this make it different from that of molality. Okay. So what is a solution basically? Solution is a combination of the solute and the solvent. Okay. So if I am making a solution of the NaOH, so there NaOH will be the solute and water will be the solvent. So in simple layman language you can say whatever present in the lesser quantity will be considered as the solute. Okay, so total volume, that is the solute plus solvent, that will be the solution. So here we take the volume of the solution. Alright, so when I say I have 1 molar solution of NaOH, what does it means? Let's say I have a standard flask, a 1000 ml standard flask, and its molarity is 1 mole. What does it means? It means 1 mole of NaOH is present in 1 liter of the solution. Okay, so this can be different also. Let's say this standard flask, instead of 1000 ml, it is of 500 ml, and I'm saying it's 1 molar solution. Still it means the same. That means 1 mole of NaOH is present in 1 liter or 1000 ml of solution. I hope there is no confusion here. So you must be wondering, like, if it is written 500 ml but I'm writing 1000 ml. The reason being is here I'm talking about 1 molar solution. 1 molar solution has always the same definition. That means 1 mole present in 1000 liter of the solution. Obviously, if it is 500 ml, then the number of moles would be different. So it's a simple unitary method. So if I'm saying 1 mole present in 1000 ml solution, then how many moles in 500 ml solution? So it will be in 1000 it's 1 mole. So in 500 it will be 1 divided by 1000 into 500. Simple unitary method. 1 by 2, that means 0.5 moles. So in this solution, though it is 1 molar, but since the volume is different, 500 ml, that is why the number of moles present will be 0.5 moles. So 0.5 moles in 500 ml, or you can say 1 mole in 1 liter of the solution. And you can get this by using this formula also. So here we have the formula of molarity is number of moles divided by volume in liter. So if I'm saying it is 1 molar, number of moles it will be volume in ml, in liter. So it is 500 ml. So in liter it will be 500 divided by 1000. So what does it means? It means number of moles will be 1 multiplied by 500 divided by 1000. So again we are going to get 0.5 moles. So it's not very difficult to understand. Simple unitary method, do it by using this formula or directly by putting into the formula here. Alright. So I hope this concept of the solute, solvent and the solution is clear. Now let's just dissect this formula further, the molarity formula, and how to get this, because it's not always you will be provided with a number of moles. Your teacher will ask you, okay, prepare 1 molar solution of or 0.1 molar solution of the NaOH. All right, so they will not tell you what is number of moles. You have to self calculate the gram that you need to find out to weigh the NaOH, and then how to dissolve this. Everything you will be done by yourself. All right, so how to do that? We know that I have already written number of moles. There are 4 formulas of calculating the number of moles, but the simplest or the widely used is when mass is given to you. So it will be given mass, which is in gram, divided by molar mass, that is in grams per mole. So if I put it in this formula, that is the formula for molarity, this will be molarity is equals to given mass in gram. Please do remember the units, it is in gram, not in kg, divided by molar mass, which is in gram per mole, and multiplied by volume of solution. Please do write the complete formula in liter. Okay, and if it is given in ml, what you have to do? You have to divide it by 1000. So we can also write it as given mass in gram divided by molar mass in grams per mole multiplied by volume of solution. Instead of liter, if I am writing it as ml, so what I have to do? I have to divide by 1000, which is going above, so it will be 1000. So this is also the formula for the molarity. Okay, so you need not to mug up anything. Just remember whether the volume is given in liter or it is in ml. If it is in ml, this 1000 term will appear, otherwise it will not appear. As simple as that. All right, so let's do a numerical based on this. Consider 14 grams of NaOH dissolved to make 250 ml of solution. Find the molarity. Okay, so here the answer is given mass is provided to you, that is 14 grams, and here in the formula molar mass is also provided. In the question, molar mass is also provided. Molar mass of NaOH is 40 grams per mole. Okay, so the molar mass is 40 grams per mole. It is always a good practice to write everything, okay, and then put it in the formula, right? So volume is 250 ml. So here we can easily calculate the molarity. Molarity, this is the formula that we are going to use. Given mass, that is 14 multiplied by 1000 because we are taking volume in ml, divided by molar mass is 40. Please check the units also. It's 40 grams per mole. So we are good to go. We can directly put it here. Multiplied by volume in ml. So volume in ml is 250. So if we solve this, we will get 1 point. Okay, so let's move to the next term, that is normality. Normality is represented by the symbol capital N, and it has a formula of number of gram equivalent of solute divided by volume of solution in liter. Same as that of the molarity. If it is in ml, you have to take into consideration the factor 1000. Okay. So now what is number of gram equivalent of the solute? So there is a relation between the number of moles and the gram equivalent, which is given by number of gram equivalent is given by number of moles multiplied by n factor. What is this n factor? I'll explain it now. Okay, but before that, from where this n factor come into this picture? Basically, we have another term called equivalent weight or equivalent mass, which is given by molar mass divided by n factor. Okay, so first I'll explain you what is n factor, and then we will come back to this formula again. Okay, so to understand the term n factor, and this is a very wide topic, so I will restrict it to only acid and base. Okay, just for the explanation. All right. So to understand this factor, we have to take into the consideration two titration, acid-base titrations. Okay, one is HCl versus NaOH. Another is H2SO4 versus NaOH. And to make the things simpler, what we are going to do is we are going to take everything else same, that is the strength and the volume. So if I am taking 0.1 molar of HCl, I am also taking 0.1 molar of NaOH. 50 ml of this, 50 ml of this. Similarly here as well, 0.1 molar H2SO4, 0.1 molar NaOH, volume 50 ml, here also 50 ml. Okay. So if we titrate here, the reactions which are going to take place here will be HCl is going to give 1 H plus ion and 1 Cl negative ion. So if I am taking 0.1 molar of this solution, the HCl will also, the H plus ion will also have the same strength. So is the chloride ion. Okay. And similarly, NaOH will give 1 OH negative ion and 1 H plus ion. So if I am starting with 0.1 molar of the NaOH, this will also be 0.1 molar, and Na positive ion will also be 0.1 molar. Alright, so here it is a neutralization reaction. HCl is acid and NaOH is a base. So it is a neutralization reaction. So what happened in a neutralization reaction? Here the H plus ion neutralize OH negative ion to give water. Okay, so here you can see the volume is same, the strength is same. So exact number of H plus ion will neutralize the exact number of the OH negative ion. So there will be complete neutralization. Okay, whereas if we take this case, so we know that H2SO4 has 2H plus ion. Okay, so this is going to give us 2H plus ion plus 1 SO4 2 negative ion. What does it means? It means if I'm starting with 0.1 molar of the H2SO4, this is going to give me 2 into zero point 0.1 molar, that is 0.2 molar of the H plus ion and 0.1 molar of the H2SO4. But NaOH would remain the same. This is OH negative ion plus Na positive ion. So if I am starting with 0.1 molar of the NaOH, this is giving 0.1 molar of the OH negative ion and 0.1 molar of the Na positive ion. So here you can see again the neutralization reaction take place between the H plus ion and the OH negative ion, but here the H plus ions are present in double concentration as that of the OH negative ion. Okay, so that is why not all the H plus ion will be neutralized by the OH negative ion. Therefore, the solution will be acidic. Okay, so from this concept, the concept called N factor come into picture. Okay, so N factor basically represent replaceable H plus or OH negative ions in terms of acid and base. I have already told you it's a vast topic. So there are other criteria also, but here we are talking about only acid and bases. So how many H plus ions are there, how many OH negative ions are there, that will decide what is its N factor is, or what is its basicity, or what is its acidity is. Okay, so this also talk about the basicity of the acid or the acidity of the base. Okay, so it's very easy to understand right now. For example, first we will talk about the HCl. So in this case, N factor is 1. Why? Because we have 1 H plus ion. Okay, if I talk about H2SO4, the N factor is 2. Why? Because we have 2 H plus ion. This also talk about the basicity. Its basicity of HCl is 1. Basicity of H2SO4 is 2. Similarly, if I talk about phosphoric acid, its N factor is 3. Why? Because I have 3 H plus ion. Similarly, if I talk about the basicity, the acidity of the base, so in case of NaOH, the N factor is 1. Why? Because I have only 1 OH negative ion. In case of magnesium hydroxide, let's say, here the N factor will be 2. Why? Because I have 2 OH negative ion. Alright. So I hope this N factor concept is clear. Now, the reason why this N factor is taken into account in case of normality is, so try to understand one thing, that molarity talk about the strength or the concentration of acid or base or solute in the solution. Okay, whereas normality it talk about the strength or the concentration of H plus ions or OH negative ions or ions in the solution. And in neutralization reaction, it is the H plus ion or OH negative ion which are reacting. Okay, so that is why normality is preferred over the molarity. Why? Because it gives you the exact concentration, like how many H plus ion, how many OH negative ions are available for the actual reaction. Okay, so that is why we have to take into account the N factor in case of the normality. Alright, so let's just do a simple numerical. Then I will show you the relation between the molarity and the normality. Okay, we'll start with the numerical. Let's say we have 9.80 grams of H2SO4 with molar mass 98.08 grams per mole present in 500 ml solution. Find its normality. Okay, so how to do this? We know that given mass is 9.80 gram, molar mass is 98.08 gram per mole, volume is 500 ml. Let's say also find molarity. Okay, we are going to find both molarity as well as normality. Okay, so in case of molarity, we know that this is quite simple or straightforward. Molarity is given by given mass divided by molar mass multiplied by volume. Since volume is in ml, I have to take into account the factor 1000. So this will be 9.80 gram multiplied by 1000 divided by 98.08 multiplied by 500. So this is the molarity of the solution. What about the normality? So normality is given by number of gram equivalent divided by volume of the solution in liter. But we have to calculate the number of gram equivalent also. So how to find that? Number of gram equivalent is given by given mass divided by equivalent weight. Okay, now how to find the equivalent weight? Equivalent weight is given by molar mass divided by n factor. Okay, so if we put this formula in the number of gram equivalent, we will have number of gram equivalent will be given mass divided by molar mass, which is again divided by n factor. So of course the n factor will goes up. So this will be given mass multiplied by n factor divided by molar mass. Okay, so this is the formula for the gram equivalent. So we can say that normality is given mass multiplied by n factor divided by molar mass multiplied by volume of solution. Normally volume of the solution is given in ml, so let's just write that in that term. So we have to take into account the 1000 factor as well. So that is why it will be given mass is 9.80 multiplied by now the n factor. N factor for H2SO4, we know that this is 2, right? So n factor will be 2 multiplied by 1000 divided by molar mass is 98.08 multiplied by volume is 500. Okay, so this is the final formula. So if we solve this, the answer would be around 0.4 normal. Okay, so don't get confused, just try to remember the basic formula and you will keep on putting it in the standard formula and you will get the answer. Alright, from this you can realize that we also have a relation between normality and molarity, because in some time in exam you will be provided with a very less time and you will be provided either with the normality or the molarity and you will be asked to find the other, right? So that is why it is very important to know the relation between the normality and the molarity. Okay, so let's just write down the formula for both. We know that molarity is number of moles divided by volume in liter, right? And normality is number of gram equivalent divided by volume in liter. Okay, and we know that number of gram equivalent, we know that number of gram equivalent is basically number of moles multiplied by n factor. So we can put it here. So normality, let's say this is equation 1. So normality is number of moles multiplied by n factor divided by volume in liter. So this is equation 2. So if we compare equation 1 with equations 2, you can see that this part, on comparing with equation 1, you can see number of moles divided by volume liter. This is nothing but, this is molarity, right? So that is why normality is nothing but molarity multiplied by n factor. Okay, so please do remember this formula. It is very, very important. Okay, and in case of dilution or acid base, we use normality. Okay, and the basic equation that we use is N1V1 is equals to N2V2. Okay, we use either this equation or we also use M1 V1 multiplied by n factor 1 is equals to M2 V2 multiplied by the n factor 2. So if normality is given, you are going to use this formula. If molarity is given, you are going to use this formula. Okay, these two equations we use. We never use M1 V1 is equals to M2 V2 for acid and base or for dilution. Okay, so this is also very important to remember. Okay, so let's just try to understand with one of the example. Okay, let's say we have, consider you have two normal H2SO4 solution you have two normal H2SO4 solution with volume of let's say 100 ml. Okay, dilute it to 500 ml and find the normality and molarity of the new solution. Okay, this is very important and easy concept. Whatever concept we have studied, you will be able to apply this. So what they are saying is they have two normal solution of H2SO4, it is 100 ml. Okay, they are going to add another 400 ml water to this to make it H2SO4 solution with a total volume of 500 ml. Okay, so what is the normality and the molarity of the solution? This is what they are trying to ask. Okay, so I have already explained you, whenever we have dilution, we always use this equation. Okay, so we can directly write N1 V1 is equals to N2 V2. 1 represent the previous condition, 2 represent the current condition. The previous condition, normality was 2 multiplied by the volume was 100. New normality you need to find. New volume is 500 ml. Okay, so please do remember, we talk about the total volume. Though we have added 400 ml, but 100 ml was already there. So total volume is 500. That is why we are taking 500 here. So in this case, the normality would be 2 multiplied by 100 divided by 500 normal. So this will be the normality of the new solution. What about the molarity? So we know that normality has a relation of molarity multiplied by n factor, right? So in this case, molarity will be normality divided by n factor. And the solution is H2SO4, right? So n factor for H2SO4 is 2. So molarity would be n factor divided by 2. N factor we have the normality we have already calculated. This is 2 multiplied by 100 divided by 2 multiplied by 500, right? So this will be 0.2 molar. So this is the new molarity of the solution. All right. So I hope these concepts were clear to you. Why do we use normality and why in some cases we use molarity? Okay, how to calculate the normality or molarity, what is the relation between these two, and from what is the origin of this relation, why do we use normality, right? And how to dilute any solution, and once you dilute it, how to find the strength. This will come very handy in lab, especially because many a time you are supposed to dilute a solution. So it's very important that you should know how to calculate the normality or the molarity of the new solution. Alright, so I think that is it for today's video, and if you have any doubt regarding any concept or any numerical in this video, you can comment down below, and in the next video we will study most probably the molality and some other concept in the continuation of the mole concept. Alright, and or the concentration of the solution, or if you have any topic in your mind that you want me to explain in the next subsequent videos, please do comment below. All right, thank you so much.